And we will have webinar moderators that will be selecting questions for the panelists to review. We usually get way more questions that we can answer, but we'll do our best. And some of the questions that the panelists may not cover, the moderators will try to answer this for you as well. So feel free to go ahead and post your questions in that questions window. Okay, so let's start talking about the panelists. So let me introduce myself. I'm going to be the host for today's webinar. I am a soil food web consultant. My name is Brian Vag, and I have a company called Sprouting Soil. And just a brief little bit about my history. I did grow up on a homestead. My parents were very much into raising our own animals, growing our own food, and I learned a lot about, farming and homesteading from my parents. But unfortunately, my parents were very conventional in their methodologies. So we used to, till the soil, apply herbicides and pesticides and fertilizers and things like that. And that's just the way, I learned and I grew up. And then when I was a child, I was very interested in biology. In fact, when I went into college, I was a biology major. But one other thing about myself is I'm a computer nerd. I grew up in the age when computers were really just starting to come about. And I took some elective classes in college on computer science. And I had a professor tell me, hey, computers are where it's at. It's going to be a booming business. And I really thought about it, and I went down the high-tech industry. I changed my major, and I worked in the high-tech industry for over 2 decades. And it was great. It was a good opportunity. It was fun to be in an industry that was just getting big and blowing up, and I felt like I got a lot from it. But I still, the background had this desire or need to be more wrapped around biology. And in fact, my wife and I ended up buying a homestead here in Northern California just so we could do that as a hobby. And I approached the homestead very much like I approached my parents' homestead, which I rototilled, I applied fertilizers and herbicides and pesticides and fungicides. And really, as an adult and looking at my food, it was very weird for me to start spraying on these chemicals where you had skull and crossbones on the packages, and then I would eat them later on. And I mean, I think that's most of us that buy stuff from grocery store don't actually have that deep a connection. But when you're homesteading, growing your own food, that was such a startling, resounding thing for me. And the other aspect is I realized my production was going down every year, and I was having to apply more of these products, and I just knew there had to be a better way. Long story short, I came about permaculture. It was my first kind of dipping my toe into resilient farming. And I found that it started working. I stopped tilling my soil. I was doing like companion plantings. I'm adding a lot of mulch, applying compost, and things were really turning around, but I still didn't understand the whys. And I ended up reading a book by Jeff Lowenfels called Teaming with Microbes. And in that book, Elaine writes the foreword. And all I had to do was I really just read the foreword and went, wow, that already answered a tremendous amount of questions for me. I started to connect a lot of dots. And I looked up Elaine online, saw some YouTube videos, and then I was like, wow, okay, that's something I really need to investigate more. And I did. So I took the courses, and right when I was in that phase, I started to kind of recognize, you know what, maybe I'm up for a life challenge or life change. And I did. I ended up leaving the high-tech industry. I started my own soil biology consulting business, and I haven't looked back since. And it has been just a tremendously rewarding experience for me now to work with farmers and making them or helping them make that transition from conventional organic to biological farming. And so even though I was not a mainstream farmer or I didn't get my biology major, I still have learned the skills necessary to be able to go out there and do this consulting work. So that's my story. And as far as our panelists today, I think some of them have very similar stories, or at least how they approach this. You're going to hear a lot more from Todd Harrington. He's a soil food web veteran. He's been in the game for a very long time. Has worked with Elaine for many years, and somebody that I think a lot of us consultants look up to as far as somebody who's been doing it in the business for quite some time. Keisha and Casey, they own a Catalyst Bioamendments, which is a commercial composting producer, and they make wonderful biologically complete compost. I'm super thankful that they're in my area because my clients, pretty much most of them, buy compost from them. And that's our way to be able to use that really good, rich, biologically complete compost. And then we have Wes Sanders, who's actually in this area as well, in Northern California. And he has his own soil food web lab. and it's Foothill Biological. And so Wes is out there taking soil samples and getting those reports out to his clients and really helping a lot of us, be able to inform our clients as far as the biology that they've got in their soil and their compost and so forth. So you'll hear more from the panelists as we get into the Q&A sessions today. All right, so before we get actually into Todd's presentation and get into the Q&A, we want to talk about the Soil Food Web Training Program. And really, the Soil Food Web Training Program is broken down into three components. There's the foundation courses, and the foundation courses is where you learn the science and the theory behind the soil food web practices. And pretty much this is where everybody starts. And some people, this is exactly what they need and what they want, and they'll stop here and just go through the foundation courses to gain that knowledge. Other people want to be able to do this more as a profession and apply some of these techniques. And there's really kind of two routes that you can take here. One is to have a certified lab so that you can actually stand up your own lab. You can do it at your house or in an office or wherever you choose to have it. And you could do biological assessments of soil, of compost, liquid amendments, and so forth. Again, this is being able to use a microscope, being able to assess those materials and determine what is the biology that is in those materials. And some people, that's where they want to stop. They want to have that lab and just maintain that. Other folks want to do more like what I do, consultant work. And in consulting, there's many different avenues that you can take. One avenue is to become a biocomplete compost producer. And so this would be making good biologically rich compost products and learning how to actually go about doing that. And I can tell you from just being in the business and working with a lot of compost vendors, the vast majority of compost out there does not have the biology that we need to really kind of drive these soil food web practices. So we really do need a lot more producers out there making really good compost. Another avenue is to become a consultant, going out to clients' locations, investigating their operation. What are they doing? What's the biology in their soil? And then putting together practices and techniques and remediation efforts to improve their land and their operation. And then also the lab. So as a consultant, you can also run your own lab, which is primarily what I do here as well. I have my own lab, I have my consulting business, and I do remediation work where I make compost teas and extracts and do spraying and things like that. So that's pretty much at a large picture how the soil food web training program goes. Now let's take a little bit of a deeper dive into these different areas. So we have the foundation courses, and like I mentioned, this is where we learn the science and the theory behind the soil food web principles. And we've broken the foundation courses into 4 chapters. So foundation course number 1 is the introduction to the soil food web. And really this is understanding what is soil? What is the difference between soil and dirt? What are the benefits of the soil food web? Why does it work the way it actually does? And the microorganisms that make up the soil food web, bacteria and the fungi and the protozoa and the nematodes and the microarthropods and so forth. And then how do you actually then apply some of those principles or practices? How do you work with clients and how do you, assess something and make some conclusions and then go on to do some remediation work? And then we have a lot of case studies. And there's case studies across all different types of growing applications from small scale farms, residential, large scale farms, golf courses, parks and rec, forest management. There's a lot of different areas that these practices and principles can be applied. So we have some case studies to be able to talk about that. So we move from FC1, which is really, again, a lot of the science and theory, into FC2, which gets into now some practical applications. How do you make it what we term biocomplete compost? And one of the things we talk about in the course is using compost as one of our primary tools to get the biology back into the soil. How do we take a soil that's very devoid of biology and get the right types of biology back into it? Well, compost is one of our primary vehicles to do so. So we'll talk about the history of compost and then, defining what makes biocomplete compost. And then we'll get into how do you make it? And there's different ways and different techniques that you can use. And we'll talk about thermophilic composting, static composting, vermicomposting, and so forth. And then making it at a small scale. So all of you could make a very small scale type of hand turn pile, all the way to very large scale production where you're making, maybe thousands of yards of compost at a time. And then also talk about application methods. How do we take that compost that we just made, this very good biologically rich compost, and apply it into these different growing systems? Then we move from FC2 to FC3, which is making biocomplete extracts and tea. So these are the liquid amendments. And we'll take that really wonderful biocomplete compost that we just made and now make a compost extract or a compost tea. And now we need to understand the differences between what makes it an extract versus what makes a tea, and why would you use an extract versus a tea, and so forth. And how do you actually, brew compost teas? What types of equipment do you need, and so forth. And then we'll talk about the application methods. You've made all these liquid amendments. Now, are you going to be doing a soil drench, or are you going to do a deep root zone injection, or a foliar spray, or inject it to through your irrigation system? So there's a lot of different techniques that you can do to do that as well. And then we get into FC4, which is microscopy. And so, I know a lot of people get a little nervous sometimes about this. You may have never used a microscope before, or have only done it in high school or maybe a little bit in college, but don't have a lot of familiarity with it. And that's okay. We spend this entire chapter first just helping you identify what are all the different components of a microscope, how do you tune and tweak it, how do you optimize it, to make it work for you. And then we'll look at the morphology, all of those different organisms we talked about. How do you identify bacteria and fungi and protozoa and nematodes and so forth? And now that we've done all this, identification of these organisms, we want to be able to count them and understand them better and get some data, from those samples that we just looked at. Well, once we have all this data, how do you interpret it? How do you know that the soil is leaning more aerobic versus anaerobic? What does a large population of a certain organism really mean? And doing some of those interpretations. And I also, find that the microscope is really important because, I use the analogy that, if you were a cattle farmer, unless you had 1,000 head of cattle, but you never saw those cattle. You never knew where they were at, never were able to see their behavior, see if they're sick or healthy. You probably wouldn't be that successful as a cattle farmer, in that sense. And what I try to invoke to my clients is that becoming micro farmers. And so a lot of my clients have actually bought microscopes and starting to do some of their own looking at their soil and their compost to see exactly how well it's working. And that really helps them, put some eyeballs and some observations onto, how it's progressing in their operations. So the microscope it is one of our primary tools to help us do the work that we do. Okay, so that's the foundation courses, and a number of people, in fact, a lot of people, they stop here. They got the education that they needed to be able to do what they want to do. But like I said, others want to make this more of a professional type of endeavor. And so we have the two routes. We have the CLP, the Certified Lab Tech Program. And in this case, now you're going to be assigned a mentor where you'll work up with that mentor for up to 8 hours. And this is all about the training on how to use a microscope, make your proper dilutions. How do you identify the different organisms, and how do you collect data, and so forth. And to make sure that we are building a very strong set of labs that have the knowledge, but also the consistency across all the labs, there is a certification. So we want to make sure at the end of this that you'll take a certification assessment to make sure that you are ready and have the necessary skills to be able to be qualified as a certified lab. And then we'll provide you also a how to launch your lab guidebook. So this is going to be a lot of information about how to stand up your lab. What kind of equipment do you need? Both microscopes and cameras and test tubes and slides and cover slips and all that kind of good stuff. And then also, really importantly, is a referral network. So your name will go on the Soil Food website as a certified lab. And this is an area for clients to be able to find you and be able to send you samples. I've already got quite a few clients coming through the referral network in the Soil Food School's website. Okay, so that's the Certified Lab Tech program. Then we also have the Consultants Training Program. So this is going to be to teach you how to become a consultant. And we break it down into 3 stages here. We have stage 1, which is how to make biocomplete compost. It's very important that you have the skills to be able to make it, either for your own hand turn piles, but then also how do you scale it large scale. And this could be either helping your clients stand up their own composting operation, so on-farm composting, or to help compost producers improve their practices so they can start making biocomplete compost. But really at this stage 1 is we have to be able to prove out that you have the skills and techniques to be able to make biocomplete compost. So you work with a mentor. So you're assigned a mentor that you work with one-on-one to go through this stage. And then we move into stage 2, which is the biocomplete liquids practicum. So this is where you're going to be making extracts and teas. So do you have the right equipment, the brewers? Do you have all the, the mesh bags and the spray rigs and things like that to be able to do this work? Then also building recipes. How do you add food sources in when you're making a compost tea, and the aeration that's required and so forth. And then really importantly, stage 3, and this is the final project. This is where you're going to take a project that you're going to work with your mentor to define, where you'll have a control that will be, the control will be the standard practices that that either you use or somebody you're working with that, in a growing situation. And then we'll do the biological plots where you're going to be using compost extracts, and compost teas. And we want you to be able to collect data in both those plots, and then we'll do analysis between the control and the biological, and prove that you have the skills to be able to transform that plot of land and do that biological farming. And at the end of that, that's when you become certified to become a consultant, and you'll go out and be a colleague of mine, helping farmers actually make that transition. Okay, so let's talk about the pricing for the program that we have. So our standard pricing is it's $5,000 for the foundation courses, $1,000 for the certified lab tech program, and $3,000 for the consultants training program. So that's our standard pricing. And with the promotion that we're offering now, the springboard offer is for the foundation courses, it's typically $5,000, and the school's offering it for $2,900. So that's a 42% discount, and it's the biggest discount we've ever offered. So timing's good, and this offer ends on April 22nd. Let's also talk a little bit about what's included with the springboard offer. So you get the foundation courses. So that's all 4 online foundation courses. That's a total of 63 lectures. And again, this is online at your pace. You have contact with Dr. Lane. So we actually run a monthly webinar for the students, and this is where you're able to post questions, and questions are selected for the webinar. And there's also a forum as well, where you're able to ask questions of the community as well as with Dr. Elaine, and to help you, further your education and those questions that you have as you're going through the course material and so forth. And I'll tell you, we have a fantastic community of students that are out there. There's a lot of activity on the forum, so you post your questions, and there's a lot of people that are chiming in and providing guidance and so forth. And then there's a lot of downloadable materials that come with the course as well. There's a course manual, there's a glossary of all the terms, there's PDFs of the lecture slide decks, reference material, and so forth. And then the school's also offering a money-back guarantee for this, so it's 30 days, no questions asked, as long as you haven't gone over 30 of the lectures. It'd be kind of awful to have you go through 63 saying, I want my money back. So we have a money-back guarantee for those of you that this may not be your cup of tea. Okay, so with that said, and we've kind of gone through and talked about the program, I'm going to hand this over now to Dr. Elaine. And Elaine's going to tell you a little bit about her history and her passion with the soil food web and how she's got where she's at. So Elaine, I hand it over to you.
Thank you very much, Brian. So with that background, I've been working as a soil microbiologist for approximately the last 40 years. When you add in the marine microbiology that I did at Texas A&M for my master's degree, it's a little bit longer. I started doing scientific experiments with my father back in middle school. When we took science, we had to do a research project, and my dad took me out on the Minnesota River, and we took samples going further and further away from a sewage treatment plant. to see how much nitrate was being dumped into the water and whether that was a significant problem. And so we showed kind of the standard result that if you drank the water that was being dumped into the river, you were going to be above toxic levels of nitrate for a human being. As you got a little bit further, because now the river was being diluted by other things, but we found several hot spots along the river where those soluble nutrients were washing out. They were being leached from agricultural fields. And so wrote that up, and my science teachers were rather interested. They wanted to take the data and show it to people. Didn't come to anything, of course, because it's one little kid with their data, and we could have messed it up or something like that. But it did kind of set the stage for me to be very interested in what we were actually doing to ourselves with agriculture, because all of these nutrients, soluble inorganic nutrients, are leaching out of that soil. As I came to understand what the biology in the soil does, there is no leaching that should be happening. If you've got decent levels of bacteria and fungi, you're going to hold nutrients in those two groups of bacteria and fungi, especially the aerobic versions of those organisms, shouldn't allow any leaching of any soluble nutrient from your system. They're going to grab those soluble nutrients, hold them in their bodies, and they're kind of like a pantry for your plant. Your plant will put out the enzymes saying what those bacteria and fungi, all those different species, should be doing to get more exudates coming out of that root system, more help from the plant. So the bacteria and fungi make the enzymes to pull the precise nutrients that your plant needs, that it requires. And then the protozoa, the nematodes, come along and eat those microorganisms, releasing those nutrients. Now, how do we large scale this? How do we take all of these interactions, the 7 overarching principles? And I'm sure that all of you can name off the 7 overarching principles. I just named 2 of those overarching principles when we're talking about nutrient cycling and when we're talking about nutrient retention in the soil. So how do we scale that up? You have a very large agricultural field. It might be half an acre, might be really large for an individual that grows a garden or something. But then with a little bit help of some equipment, you could be very easily working with 20 acres or 50 acres. You start getting larger size equipment to help you move things around, help you apply things out on that field. Typically the problem we're dealing with, or what we're trying to do, is last thing actually in the fall, if you're lucky enough to get a client that starts at harvest time, they see that their yields are going down, that they don't have the flavor in their produce. They want to do something to not be putting on the toxic chemicals that result in leaching coming from their soils. We want to have equipment that we can put compost out on the soil, and perhaps, if necessary, if you have compaction layers, you're going to want to till that material into the soil. Or maybe you wait until the springtime and you put those applications in the rows where you're going to be planting the plants, where you're going to be going down the furrow, so that you're getting all this good biology concentrated in that area where the plants are going to be planted, where the seeds are going to be placed. So all that good biology is right there where the root system can benefit from that. So one application in the fall, one application in the spring. Then we switch to strictly liquid amendments, where we can inject into the soil using a metal rod with a pump on it that will pump the compost extract down into the soil, and again, get that biology around that root system. Maybe when you're planting, you're going to, down that furrow, you're going to drop a little bit of compost extract in furrow before the time with the seed, drops that seed right on top of where you just put that nice application of the compost extract with all that great biology. So when and then you close, well, let me say first, if you had a start, you could just drop the start right on top of that spot where we had placed that really good set of biology using that compost extract. From then on, you're really going to be looking at above ground kinds of issues. If you get the biology perfectly right in your soil right away, and it happens that way, not that often, but it can, then we see that that biology is going to, from the soil, is going to get up onto the leaves. If that's not quite right yet in our soil, then we need to come out and we need to apply foliar applications of this biology, because when you cover surfaces, and it doesn't matter if it's the root system of your plant or the above ground part of your plant, the leaves, the stems, the twigs, the flowers, the fruit that you're producing, you need to get that protected from the diseases and the pests. You need to make certain that a certain amount of nutrient cycling is going on the surfaces of the plant above ground. But that's pretty much the applications that you need to make. You probably want to check your soil and make certain that that biology in the soil is balanced the right way. I was just reviewing a paper for publication in the scientific literature where they had taken a whole bunch of different composts and measured the biology in those different composts, and probably only one out of the whole list of composts would actually pass muster from our point of view, where it would actually give you the bacterial fungal ratio that you needed for the plant you wanted to grow. And that was the part that the people, the scientists writing the paper, completely forgot. They were trying to grow lettuce. They were trying to grow, I don't remember exactly, but it was something like Brussels sprouts and kale and tomatoes. And so they were pushing fungi, the fungal to bacterial ratio had to be up around 2 times more fungi than bacteria. And so the results that they got didn't have any correlation with plant production. And I looked at the results and I went, well, if you understood the soil food web and how that food web balance changes as you go through the stages of succession, as you go from bare soil to plants like the kale and the Brussels sprouts, to the lettuce, to the potatoes, to the shrubs and trees and commercial forests of any kind, getting more and more fungal as you go along. You can't expect that the same compost is going to have the same effect on different plants, because the cole and the kale crops require highly bacterial dominated. You want actinobacteria in there, but that's not the case for the lettuce. That's not the case for the tomatoes. So there should be no expectation that all of those composts were going to affect those different plant species in the same way. So of course there's no correlation. And I just want to emphasize to everyone that you have to not be led astray by scientists that don't really understand the soil food web. Hopefully we can wake them up and get them to understand, but we need the data to show people. So on that note, I will turn it back to Brian, so you can forge ahead.
Turn it over to Todd. Thank you, Elaine, so much for the introduction. Okay, so before we hand this over to Todd, we want to talk a little bit about the next webinar. So the next webinar we're going to have is Save Your Soil on April 21st, 2021. And let me just ask the panelists here really quick. I did lose connection for a minute, and are we on the next webinar slide? Has that moved over? You guys can see that, right? Just checking to make sure that my computer's back in sync.
I'm not really sure, what it's supposed to be. So
yeah, look.
Okay, it should say next webinar. Fantastic. Okay, thanks.
Yeah, and
thanks,
that's what it does.
Okay, great. Lost my internet, so I just want to make sure I'm all back in sync here. So the next webinar is going to be on April 21st, 2021 at 11 a.m. Pacific time frame. So that's 7 p.m. London time frame. And this is going to be an open Q&A session. So we won't have a guest presenter. It's going to be a lot of Q&A. So if something you want to join, ask a lot of questions, feel free to do so. We'll also be talking about the science application methods behind the soil food web. So again, this gets a little bit more into the details. And then we'll have, again, panelists, consultants, lab techs, compost producers will be on this as well to be able to field those questions. And, we'll be talking about the soil food web and nutrient cycling and soil structure, weed suppression, disease and pest inhibiting, sequestration of carbon. There's a lot of different topics that we definitely can cover in that webinar. Okay, so without further ado, I'd like to be able to hand this discussion now over to Todd Harrington. So Todd, why don't you take it away?
Okay, well, thanks, Brian. That was fantastic. And Elaine, thank you too. I'm excited to be here again. And I don't know if I feel like I'm an old guy here with the term veteran, but I'll take it for what it is. And so I guess when it comes to when the rubber meets the road, or shall I say the microbes meet the dirt, it's when it comes to the real world applications of doing the soil food web approach, I've had the opportunity to work on some pretty big projects, but this is a great project here because really I hadn't really got involved in anything really big or large scale. Elaine was talking a little bit about kind of doing a large scale applications, and so this was a great opportunity for me. And we had formed a group with Elaine. There's probably maybe a dozen of us back in the early 2000s, and this one individual, Ray Gore, I had met. He was one of soil food advisors, and I give him a lot of credit here on this PowerPoint because he did a lot of the legwork when it comes to getting all the data and also working with the farmers and getting the the testimonials, which we'll look at the very end here. So if you want to go to the next slide for a second.
Sure.
Are you able to, I know we kind of lost you, Brian.
Yeah, so. It seems like my computer's being a little bit slow. So it should, I clicked on the next slide. It should be there in just a second.
Oh,
sorry.
Yeah,
oh.
I guess not.
Don't think it's
Brian figured that out. Kind of give you a little history here. So again, this was back in the early 2000s, and which here we are, fast forward, and yet back then we were already scaling up, and we saw some pretty amazing results in the early 2000s. So again, this is something that's been around for a while. It's nothing new. Elaine, she would politely say, sometimes people are a tad slow when it comes to figuring this stuff out. And again, we've been doing it for quite a while, and there's quite a few farmers out there and people in agriculture and horticulture that have been dabbling in this stuff for the last couple decades. But just recently has it really started to take off because people are starting to wake up, and they're getting a little faster at understanding this stuff. So anyways, so again, I started working with this gentleman named Ray Gore, and I give him a lot of credit for what he did back in the early 2000s. And he really scaled up what I was doing on a much smaller scale, especially when it comes to making compost extract versus compost teas, or activating the biology. So this was out in Idaho. They had been in business for only about, I think it was about 3 years when I met them. And within that 3 years, they were like a $500,000 business, and they had a few consultants. And all they did, which was kind of unique back then, is make compost extract, compost teas, and they consulted. That was their primary business. So it was really, fascinating to see how they scaled this up. And, we don't have a lot of time to review the 50 slides that I have on this PowerPoint, but you can see in the foreground or to the left-hand side there, that's just one of the pivots that we were actually injecting the compost extract that was actually activated in that tank. And we were applying it anywhere between 5 and 10 gallons an acre. That particular picture is probably doing an active, and it was probably potatoes, if I can't quite see it. But anyways, and then we actually had a full-blown compost extract center, and we were making our own vermicompost, our own compost. and we were customizing it for some of the projects, and then we were extracting into large vats or batch tanks that you can see in the slide there to the left of the service. There's probably those, I think those were 1,000-gallon tanks back then. Now we've been using 2,500-gallon tanks and batching up probably about 10,000 to 20,000 gallons a batch. Or, you know, with the extractor, it's really continuous, so you can just keep making it and making it. But I'm just going to talk a little bit about some of the projects that I was exposed to, like the pastures, the alfalfa fields, the potatoes, the beans. We were doing corn. I mean, they were into everything out there. But, you know, typically, they're probably their largest clients were the potato growers, being out in Idaho. So, but I saw some really amazing things when it came to the results that they were getting with just one application of compost tea and extract, and maybe some other nutrient applications. So, Brian, if you want to just go to the next slide for me.
Sure. I think I have about a 10-second delay, so I'll try to interpret or get your timing right.
Yeah. So
next one's come up is the sugar beet production is where you're at.
Yeah. So we were, you know, one of the things that was kind of neat that I was involved in like a second and third shift. We were actually producing. We had to produce so much extract that we had a guy come in the evening and a guy come in at night, and we were producing. I think one day we got up to 50,000 gallons, and because the tanker would come, we had a 3,000 or 4,000 gallon milk truck that was converted to the extract, and that basically would pull up, and we'd have to fill it up, and we'd empty out all the batch tanks, and then we'd have to start another batch when he came back. But that particular truck would go out and service maybe like a dozen 500-gallon cone bottom tanks that actually had aeration in it, like you saw earlier with that pivot. That was actually one of those 500-gallon tanks that was at one of the farms that we would service with the extract. And then we'd add some food, and then we'd activate it, and then it would had a timer, and it would automatically inject into the pivots. So that's what you saw earlier. So here on the left-hand side, we had some conventional sugar beet fields, and they were producing about 26 tons an acre. And you know, basically we're looking at between 12 and 14 for the bricks. And then after just one application of 7 gallons an acre of compost tea. So when I use the term compost tea, it's an active versus maybe it would say an extract. So just by definition, this was an activated extract. So that 7 gallons is activated, just for defining here. And so that one application, you know, the next time they harvested, they got 37 tons an acre. And that bricks level had increased from 13 to 14 to over 18. So that was, you know, a 42% increase in just the sugar content with that one application. So when I started seeing this stuff, I said, there's definitely something here. So, you know, it really, you know, I figured, you know, I got to get involved in this and see, you know, what is it these guys are doing, and, you know, how are they doing it on such a large scale? Because that's the future of agriculture as far as I'm concerned. And even back then, I kept thinking, you know, there's going to be a paradigm shift. It's going to happen. It's just a matter of when, not a matter of if, right, Elaine? So anyways, if you want to move on to the next one for me, we can see what's next here. But it was really exciting to see this whole process scaled up the way that they had scaled it. And they were really efficient at it. And one of the things that made them so successful was their consistency with quality control, disinfecting and cleaning, and microscope work. We actually hired a full-time lab tech. His name was Shindrapa. Became a friend, and he ended up coming to work for me for a couple of years. So we were testing everything. We were testing the extracts in the batch tanks. We were testing the extract in the sprayers. We were testing the extract coming out of the sprayers. We were testing the soils 2 weeks later. So, you know, how do we know if it worked? Well, we were testing it. So that's how we knew. So on the left-hand side, this was alfalfa. So it was really interesting, the alfalfa fields out there in Idaho. If you look in the horizon, you could see really healthy spots and really unhealthy spots. And then when you walk down these fields, you could see all the unhealthy areas, how anaerobic and compacted these areas were, because we were looking at it with a penetrometer, and we would only get maybe 4 or 5 inches. And, you know, the areas that were nice and green and plush, the penetrometer would go right in. So it was really obvious, not only with the penetrometer, but also visually. You could see how the alfalfa was stunted. You could see how the fields, the rows were thinner. And so the penetrometer is just a great tool to monitor this compaction in the soil being so compacted and anaerobic. So then, again, this was just one application of 20 gallons, and the ACT is an activated compost tea, and 5 gallons of organic gem. And so what organic gem is, just a fish hydrolysate. That was the company they were using back then. And then this particular field, they actually had the opportunity to put about 0.5 ton of compost. They actually had compost made, and I doubt very much it was a biocomplete back then, but it was, I think it was pretty sure it was a poultry manure that was composted. And then there was also, they used, I think it was 2 gallons, it looks like, of liquid calcium and boron, which was something that showed up very deficient in the soil test. And the compaction basically started to alleviate quickly, and they, I guess within about a year or less, they went from 4 tons to 7 tons, and in those 3 cuttings. So it's really impressive to see what they did with alfalfa. And I know from another project in Texas, which they can't grow alfalfa very well in Texas because of the root rot diseases. There's a few folks doing the soil food web approach down there, and that was back in the early 2000s. And they were actually able to get 3 cuttings down there in Texas with alfalfa because they were applying the liquid biological amendments, the compost teas and the extract. It was really impressive to see how they had, kept the root rot disease at bay with the alfalfa. So I don't know if you folks are familiar with the root rot diseases with alfalfa and further down south, but it's a real issue down there when grown conventionally, not so much regeneratively. So, Brian, if you want to move to the next one.
Sure. It's going to be going to grasses next.
Yeah,
Sorry
so
for the delay.
pastures has been really interesting and really fun to work with. I think they're probably one of the easiest crops to see an improvement using the soil food web approach, because it's pretty resilient. But at the same time, when you manage pastures with synthetic pesticides and fertilizers, you can really see how stressed out these properties get. And the thing that when you really notice it is when the stress and strain comes in, the hot weather or the humidity or the excessive rain. That's when these pastures really fall apart that have been managed chemically or conventionally. But anyways, this was a field that was actually being managed by SSI. That was actually one of the Horizon Dairy fields, and they had a pretty big project. I think it was a 3 to 5 year project. And most of you might be familiar with Horizon Dairy, but they're an organic company. They've been around, one of the oldest organic companies around when it comes to what else do they produce? Obviously yogurts and milks and dairy and so on and so forth. But we definitely saw a big improvement when we started managing it organically or sustainably with regenerative practices like the compost teas and the extract. But high feed value in the tea areas was really obvious to us, and they increased their protein content in the grasses from 4 to 6 and even 10%. And I think there might be another slide here with that pasture. It shows the pasture in the background, the one that was being managed chemically. It was kind of, is there another slide to here? I think there is.
It's on its way. Yeah. Yep. It's on its way.
Yeah. So this is a good picture because you can see, there it is. So this is one of Horizon's Dairy's, one of their many fields that we were managing biologically. And so that control pasture on the left-hand side, they were trying to manage it organically by putting 8 tons of manure, which was probably completely putrefied and really high in phosphates and nitrates and gypsum. And obviously they weren't getting very good results with that, if any at all. Probably make things worse, if anything. But in the control, you can see in the foreground was the control, and in front of us we can see the managed biologically. So they were applying 20 gallons an acre of the activated compost teas with fish, 6 gallons of fish hydrolysate, and basically the weight gain again was like 25% or more. The only complaint they got was that they had to bale. It was excessive. The client wasn't used to obviously baling as often because the crop is growing so much better and so much healthier. So that was their complaint mostly. And I know they had chickweed in there, but it was not nearly as invasive as it was when they first started. Chickweed was a huge problem. And then by the time, after a year or so, that chickweed just started to just kind of go away. It was there, but it was being managed because it was being outcompeted. This is all about competitive exclusion when you manage the intended crop, especially when you do it biologically. So that's one thing I've really noticed over the years is when you manage the biology for that particular crop system, a lot of these invasives just kind of start to peter out, and they're just not nearly as invasive, and they just kind of peter out, and they're just not a problem. But we sometimes we have to transition and manage some of these weeds chemically, but very minimal and only spot treating. That's something we talked about, I think, last time. So I think, is there one more slide?
Yep, potatoes. Potatoes are next.
Potatoes, yeah. Potatoes are big. So that's something that they really accelerated in, is managing potatoes, and they saw huge gains. The typical back then was about 280 sacks an acre. But when we started, when they started doing the compost teas, the extract, and some nutritional things were done, we were definitely looking at chemistry and making some applications with some trace minerals or even, calcium. There's a lot going on here, but this was an activated compost tea plus organics, nutrients. So they went from 280 to well over 400 sacks an acre. So that's, as you put there, it's 42% increase, which is really impressive. I mean, that dollars and cents wise, that's a big jump. And the other thing that kind of disappeared is they had some diseases and a lot of insects. What was it? Yeah, the Colorado potato beetle was a big problem there. And I contribute a lot of that because of the conventional system. Just the pesticides they were using, the insecticides and the fungicides just really made those plants really susceptible to insects. And we see it all the time with the low brick numbers and, the compacted soil. And so anyways, this application that was done on that particular field with those potatoes was about 20 gallons of activated compost tea, and that was done in the spring. And then 5 gallons of fish hydrolysate was also used. And so again, these before and afters are either 1 or 2 applications, and that's it. So the reason that they were so successful with 1 or 2 applications is because they were testing, and they had really good vermicompost that we were using. So by definition, even back then, we didn't have the terminology biocomplete, but it was very, very good biology that we were making in that compost. And the only way that we knew is that we had a full-time lab tech actually looking at this stuff on a regular basis. And we had to make improvements. We had to make adjustments because sometimes things didn't go, the way we wanted it to. It might have been too bacterial. There might have been issues with the protozoas, but we always nipped it in the bud because we were constantly monitoring the biology. And that's something Elaine talks a lot about is, how do you know unless you test? And I think that's one of the reasons these folks were so successful is because they spent the money, they spent the time hiring a lab technician and doing all the testing at the early stages of these projects. And, once they got dialed in, then, you don't have to spend the time and money testing so much. But in the early stages, I highly recommend that you spend the time and the money doing the testing. And there's a lot of great techs out there now that Elaine has put through the course that can do that for you. Back in the day, Elaine, I don't know if we had I could probably count in my hands how many people were actually under the microscope then that really knew what they were doing.
Yeah, you had to send stuff into the lab in Oregon, and when you live in Connecticut or someplace far away, or where overnight mail isn't really very much overnight mail, it's a problem. Yeah. So that's why we saw the need to expand and have people all over.
Yeah, I mean, now I have clients all over the place, and I go, you know what? I think there's someone there that can do that testing for you, and so that's really exciting that we have a much larger gene pool to pull from that can do this for us. So basically, the bottom line, the company Sustainable Services Idaho was really successful, and they were ahead of their time as far as I'm concerned when it came to large scale compost tea and compost extract application. It was really exciting to have been involved in it, and I learned a lot being involved with this operation, and it allowed me to really learn how to scale up. And I just, from that experience, I've really just improved the processes just by doing and having the opportunity to do all these other projects. So Basically the bullet points here for this particular company was, farmers were able to dramatically reduce costs by replacing fertilizers with compost teas, compost extracts. Saw huge gains with potatoes, 42% with potato yields. The peas were really amazing because they were really aggressive with some of the pea projects. 136% increase. That's pretty impressive. Sugar beets, we saw a lot of hammered sugar beet fields that really came around after they started putting it on the biological program. Weight gains in the animals with the Horizon Dairy. And, if we can, Brian, I think we have some testimonials. I think what was really important, and what was really intriguing was every single client they had actually testimonials. And these testimonials were handwritten and signed by the client, by the farmer. And as you can see, we've got one over here back in, looks like August of 04. This particular farmer was growing corn silage. And so if you can see, these are basically the questionnaires of the testimonials we give our clients. And, this one in particular, they were growing corn silage, and previous crop in 03 was the same. Products applied and action taken was they used, looks like a compost, and I apologize, it's been a couple years since I looked at these. But the drench was, looks like 15 gallons of compost, probably extract. And then fish at 5 gallons an acre, and a foliar had 5 gallons. That was probably an activated compost tea. So it says results, and what have you experienced? It says less watering use, more mellow soils, better overall crop. And then we had, is this a general improvement over the previous year? Yes or no? Yes. Have you seen an improvement, if any, of the following areas? Increase in yield? Yes or no? Yes. Increase in yield? If so, estimate amount? 25%. Increase in quality? Yes or no? Yes. If so, estimate the amount? 20%. Decrease in weeds? Yes. Decrease insect pressure? Yes. Better soil structure? Yes. Less watering? Yes. If so, estimate savings? 30%. So other comments, very good service, knowledgeable, and I think that says field something. Anyways,
Field man.
Yeah. Hey. And then, so here we got another one from around the same time. Looks like alfalfa. I think it was probably that alfalfa field that we were just looking at. The previous crop was the same. Looks like they did a drench, foliar, and fish hydrolysate. So results, and what have you experienced? And it looks like my hay tested on, I can't quite read that, Brian. You're pretty good with that. Can you read that?
My hay tests on pasture have increased on first application last year and second crop by 4% increase.
There you go. Good job. So, these are fantastic testimonials because they're handwritten and actually signed by the client. And again, everything seems to be pretty positive with these testimonials. This one in particular, improvement over the previous year. Yes. Have you seen improvements in any of the following areas? Increase in yield. Yes. Quality. Yes. Weeds pressure decreased. Yes. And so on and so forth. So, that's to me is what really, I guess encouraged me to move forward with the science. And, again, this was a great opportunity for me. So, I'd love to open it up for questions, and I'm sure there's going to be quite a few Q&As here, but unfortunately, we don't have a lot of time to go through all the different projects that they had that I was involved with, but this is a good stepping stone for folks out there that might want to get involved in more large scale biological compost teas and compost extracts. So with that said, I'll hand it back over to you guys.
Thanks, Todd. And I think this is great. Like you said, this was a big stepping stone for you to get into that large scale. And I mean, since then, you're doing a lot of large scale stuff, right? I mean, large scale is your biz now, correct?
Well, I really enjoy the challenge of it. And again, some of this stuff you just can't read in books. It's just, it's unfortunately some of it's trial and error. I got to admit, but most of my clients have been really patient over the years, and they know that some of this stuff doesn't exist. We have to forge forward, and we have to design and develop and be as creative as possible, because every project seems to be different. Even though what's great about the Soil Food Web is they give you the tools to be creative, and that's what's really exciting about the Soil Food Web program and all the different people that are collaborating through the Soil Food Web approach. They give you the tools to kind of go out there, and some of the stuff you do have to figure out, but it's that creative momentum that I think we're all have that advantage being involved as this group. So anyways, I'm doing all the talking here, and I don't know how much time we have left. So,
oh, we got plenty of time. Yeah, it was great, Todd. Thank you so much for showcasing this. I think it's good for people to see that. Yeah, you can do it yourself on a small scale in your homestead or your urban lot, or even suburban type of lots. But all large scale applications are happening now. A lot of my clients are large scale, and I agree with that point that you made too about we're trying to apply these techniques, and that's what I like about the school. It arms me with the knowledge, and it also gives me a lot of different techniques that I can use. And then you partner with your clients, and you figure out how to best apply that into their environment. And I also do believe too that it's a mindset change for your farmers that's very important. Especially if they're very down that conventional route, getting them to become micro farmers and understand how to the practices they do, are they harming biology or are they benefiting biology? And once they start to get in that track of what I'm doing is benefiting biology, then that's really when you start seeing a lot of successes from their standpoint.
Yeah. And I think also, as a Soil Food Web practitioner, we're also problem solvers. Like it or not, that's what we do. And so, there's a lot of forensics involved, and that's what I really enjoy the most is trying to figure it out, and it can be really complex, but at the same time, it's really basic when you think about it. And once you learn the basic tools, especially with Soil Food Web, it all starts to make a lot of sense. Plus, we have such a huge group now that we can really, help each other out when there's, problem solving with all the different crop systems that are out there.
Agreed. It feels like there should be NBC should start a CSI Soil Food Web series.
Yeah, I know. We talked about this before.
Yeah. Exactly.
Yeah.
Okay, thank you so much, Todd. And now we're going to go ahead and move into our Q&A session. But before we answer your questions, we are actually going to ask all of you a question. So we have a quick poll. It will probably be up for about 30 seconds. And we've asked this poll on all of our webinars. And really what this is what best describes where you're coming from. Are you coming from a farmer, agriculture professional, or are you coming from more of an environmental activist perspective as far as why you joined today's webinar? And it's good for us because it helps us be able to target, who predominantly is looking or trying to find out more about the Soil Food Web. And we're about 50% answered, and this is very similar. We typically see anywhere between 60 to 70% in the farmer and 30 to 40% in the environmental activist. So I think this is almost pretty spot on. I think we've had one webinar where it was almost even, but other than that, it's all been about these numbers. So thank you everybody for participating in the poll. Okay, so now we're at the Q&A session where we're going to answer your questions. So the first question comes from Jean, and Jean wants to know, love to know how the consultants got their first clients. All right, I'll go ahead and take this one to start with. For me, my first client, that wasn't my project, to become this consultant or the CTP program, was actually because I went and did some speaking engagements. Just in the local area, there was some farmer groups that wanted to know more about the Soil Food Web practices, and I took the learnings I got from Elaine and put together a slide deck, and I just went and I talked to this farmer group. And I think there's about 30 or 40 people that were in the audience. And we talked for about an hour. There was a lot of excitement and enthusiasm from the people that were there. And afterwards, people came up and started talking to me. And sure enough, by the time I got home, I had an email that said, "Hey, I want you to come take a look at my place." And that's how I got my first client. So who else wants to talk about their first client?
I think we got our first from somebody who bought compost. They bought the compost. You know, they were ordering a huge amount of compost, and then they started like using it right, and then they were realizing that they were like, "Am I using this right? I'm not sure." And so they actually reached back out to us and were like, "Hey, if you guys actually like, can you walk us through how to use it?" And we're like, "Absolutely." So yeah, it's kind of been through that. I mean,
How
that's
odd that you
actually,
ask.
yeah,
Yeah.
and that's actually how we get a lot of our clientele.
Nice. Todd, it's been a while for you for your first client. Do you
Oh,
even
man.
remember?
Other than Elaine, geez, you know, my first client, boy, you know what? I got a good story. So my first client, I think, kind of my first client, and this was, I was working more in the horticulture industry, and I had done an internship because I'm also an arborist by trade too, and I had gone to school for arboriculture also, and I had, yeah, I was working for that company, and I was going to a client's property, and it was actually after I just had worked for this company, I was actually on my own, and God, what year was that? That was 19, not 18, 19, 19, wait, it's coming, 1990, no, 1987. So, and I actually, so I drove into the property, and I see one of those little yellow signs, right? You ever see the yellow signs when they put pesticides on property? And it was early in the morning, and it was like a dew. It looked like it had rained out because the turf grass was all kind of wet, but yet it didn't rain. It hadn't rained yet. And there was a nice, clean, new sign there, yellow sign. So as soon as I got out of the car, the strong smell of chemicals, like, almost knocked me over. You know, I was just like, whoa, it was really strong. And these two beautiful golden retrievers come running around the corner. And I still see this really vividly. Come running around the corner in this wet grass. And I put two and two together. I'm like, strong chemicals, wet grass. Now, here are these two beautiful animals running through these pesticides. And that was like an epiphany for me, a huge paradigm shift for me. And I had been applying the pesticides with the chemical companies and the tree companies, and that set me to, a whole nother direction when I saw that. What was wrong with that picture? So anyways, that was my first client. As far as I'm concerned, that client, as soon as I told them, this isn't right, and they kind of said, yeah, this isn't right. Why did they just treat this and not tell us? And the dogs, can you imagine? So anyways, that's that. I think that was my first client.
Nice.
Lived in my brain.
Wes, I know it's not your consultant, but as far as do you remember your first lab client that came in?
I'm not sure which was my first one, but I'm pretty sure that it came from just someone looking at the Soil Food website and calling me up. And at the time, I mean, this wasn't that long ago, there was only a handful of us up there. So it didn't, it was not surprising at all. Pretty quickly, someone calls me up, and before long, I had, a handful of clients that still keep coming back to me. Todd mentions, doing pasture in Texas. A guy that keeps coming back works with a bunch of pasture people in Texas. He's an agronomist, and he just keeps sending me samples over and over, and that's awesome. He was one of the early ones, but yeah, that was where my client ball got rolling, so to speak.
Right. And Elaine, how about you? Do you remember your first client?
Back in 1981. And it must have, for me, being in academia, I was invited to come out and give talks to all kinds of people. And then people would call up afterwards, or, during dinner or whatever, they'd kind of crowd around and, well, how do we get hold of you? Isn't there somebody local? And we had a few graduates. I had a couple of graduate students that to this day are still doing work with clients. So people keep popping back up and surprise, they're still doing this, and great. It's another person that we can put into the list of coming on board and telling the stories of how they've managed to survive for these many years. when you first get started, what you want to do is go around to all of the grower groups that are in your area. Find out who they are. There's hydroponics grower groups, and you can go and give a 15-minute, half-hour talk to them. Potato growers are a good one in our part of the world. Mint growers, just go find out what the local co-op, what are the classes that they're teaching, what are the grower groups that are meeting in your area, and go out and give talks to them. They're often organic growers that are going to have meetings, and they typically love to have us to come out and speak. You just have to kind of tell them that be real careful about saying you don't really have to till to get rid of the weeds. And rotation is something else you don't really have to do. But find the various grower groups and go and give talks to them. And usually that's more than enough. And then make sure you have your name up on our website, because that is a good lead for a lot of people.
For sure. The referral network helps out a ton. Okay, let's jump to another question. This question is from Jean, and Jean says, with the correct biology in the soil, is it necessary to rotate crops, i.e. legumes to leafy to fruit to root crops? And we all know this answer. Who wants to take it?
Wayne already did.
Somebody
Yeah,
said
exactly.
something about that. Yeah, and it's
Shake
because
your head.
the two reasons that you rotate are because if you keep growing the same plant in the same place for a very long time, you get all of the diseases in there, and now your plants are being hit by this disease and that disease and this other disease and this one, and they can't make it. Except if you maintain the diversity of the microorganisms in the soil by putting in compost that has that massive diversity in it, then you don't have to worry about the different diseases. They're going to be taken out by the beneficial organisms that are specifically meant to take out those disease-causing organisms or the parasites. So no need for the pesticides, no need for rotation if that's your only choice. The second thing, rotation, usually people say you have to rotate because this plant is going to remove all of this nutrient in the soil, so you've got to move this crop over someplace else. And I'm always like, don't all plants have to take up those nutrients? So why would growing a new plant in here, doing the rotation, why would growing a different plant in here make a difference? So if we're maintaining the biology so that those bacteria and fungi are going out and grabbing the nutrients, bringing them into the root system, the predators come into the root system and eat the bacteria and fungi, releasing those soluble nutrients. As long as we get rhizophagy going, which is one of the newer discoveries of how plants pull nutrients into their body, as long as we get the right mycorrhizal fungi growing on those root systems, you don't have to be rotating your crop. Just make sure you're getting the regeneration of those organisms back into your soil. And if you're not putting anything toxic out there, you're going to maintain those organisms, and you shouldn't have to keep putting on all the compost and the compost teas, etc.
Agreed. And it's so beneficial not to have to get into those rotations. If they can keep on planting the same fields, same product, over and over again, I think overall it benefits that farmer. Plus, a lot of farmers have to get into the fallow fields too, if they're trying to use that disease suppression. So it's not an efficient use of land either.
Yeah,
Yeah,
I think
I don't.
Anybody else? Go ahead, Tom.
Yeah, one of the things that we see, and one of my clients has really got a lot, really getting into cover cropping now and diversifying those cover crops, because when you have a diversified mix of cover crops, then you have a diversified exudates, right? I mean, all the different plants are putting out different exudates, which are encouraging different bacteria and fungi. And so you create that diversity, and some of these fields are so toxic. When we first started with them, it's like, oh my gosh, this is going to take a while. Sometimes if they can afford to rest that field, even for a year, just let all the weeds come in and fibritize that soil, just allow it to rest and get those exudates in there from other types of plants, including obviously the cover crops, they're going to be way ahead of the curve. And so, there's something to be said about cover cropping, and it's obviously really taking off on rotating cover crops and diversifying those cover crops. So, I'm really excited to see, some of my clients really getting into the cover cropping part of the operation on these big fields, they're really, and looking for cover crops that aren't as antagonistic and competitive with the intended crop is really important too. And some of these low growing prostrate cover crops that are perennial in nature are really beneficial in the long term. And people, a lot of, even the people in orchardists and vineyards are looking at these, perennial long-term systems, and they're really seeing a benefit from it.
And that's where we as so food web people we need to add that to our bag of tricks, exactly which short, low growing cover plants, ground cover, whatever you want to call them, which are the ones for which crops, and what stages of succession, what's the mycorrhizal fungi. We have a few things to figure out about those low growing plants. So there's plenty of research that needs to be done so we can find out what's best under each conditions.
Yeah, I mean, with the low growing plants too, you've effectively removed the monocrop as well, right? You might only be harvesting one thing out of the field, but you're not growing one thing in the field anymore. You've diversified the entire field, and so yeah, it's just a way better system for everything to be compatible with one another.
Yeah,
I've seen some pretty successful rotating, actually leaving the soy in place and just planting corn right into the soy fields. And they've been able to grow pretty successful together. Obviously, the intended crop that following season is corn, because it's not going to outcompete vegetatively. But people are really looking into being a lot more creative with rotating and leaving certain crops in play.
Yeah, here in California, we have a lot of orchard crops and vineyard crops. And it's really frustrating when you drive miles and miles and miles through these agricultural fields of just bare soil, underneath the trees, underneath the vines. And just, we have water problems here in California. The amount of evaporation that's occurring and water loss is insane. It's encouraging, a lot of my clients, we're looking at perennial cover plants to maintain that solid cover on those systems year round. And moisture management, that's a key thing, especially for areas that are in drought, prone areas. We really need to make sure we get a cover on that soil. Okay, we kind of made a little bit of a tangent there, but that's all right. I think that was a good discussion. All right. Let's jump to a question from Greg, and this one's for you, Todd. Greg asked, Todd, on this project, were you doing plant tissue testing in conjunction with soil, tea, and compost testing?
Oh man, what a great question. I sure wish we were. We were doing, I know that they had done a few tissue, but not sap testing. We've really dove deep into sap testing over the last decade, but back then, it wasn't that big of a thing. They were sending samples here and there and doing tissue testing, which I don't think is as accurate as sap testing. But they not nearly as much as we're doing now. They did do some, but not a lot. And that's why you see in that PowerPoint, there was some mention of a nutrient spray and like boron or molybdenum or moly, whatever it might be. That was related to a tissue test. There's no doubt they were definitely doing tissue tests, but it's not nearly as big as it is now. I really think we really promote sap testing more for looking at or I would say supplementing those deficiencies that aren't in the plant yet until the biology, because sometimes it takes a few years to set the stage biologically, as you guys know, with some of these really toxic soils. So during that transitional phase, we will supplement nutrients based on sap testing. John Kemp does some great workshops talking about that. But I think it's a good tool to have in the short term. But in the long term, like Elaine said, most of these soils have everything the plant needs. It just doesn't have the biology there to unlock it.
Yeah, I think there's, like plant sap testing, tissue analysis, soil chemistry reports. They're all, additional data points. And like you mentioned, Todd, we're investigators really at the end of the day. Having a rich set of data to be able to then interpret and make some analysis is really important. And that's just another tool that we have in our tool belt. Okay, anybody else want to make any comments? All right, thanks, Greg. Good question. This question is from Begald, and this one's for Keisha and Casey. We have green waste dumped at our village landfill. Can we safely turn that into compost without fear of contamination? Any guidelines available?
That's a good question. I think that if you have a strong enough culture already started, that a lot of those toxins that might be present would be broken down by the biology. But for us, we've found that the one thing in our compost pile that can really throw everything off is treated grass. We buy a lot of hay, or we used to buy a lot of hay, and that was the one variability that would just stop biological growth. Like, we just wouldn't have fungi growing, we wouldn't have a lot of diversity, produce wouldn't be showing up. So we actually started growing our own green material. And often when we're thinking about really scaling up with the compost to, a more green waste facility style size lots, we're still considering growing our own green material for the piles. So I feel the wood chips, like wood waste, might be a little bit better. They're getting really good about sorting out chipboard and pressure treated lumber and things like that. But that green material, I mean, the chemicals are still being used, abundantly all over the place. So who knows what cocktail of chemicals we're going to get. The other thing is, if it's still green, if it's an actual green material that's fresh, it goes off very quickly. You can see, if you cut your lawn and pile up that chopped up grass, it's going to turn gray and get really hot and start to go anaerobic fairly quickly. So that's another thing to think about with the actual green material, if that's what you're talking about. Or perhaps to clarify, you might just be talking about the green waste in general, which is mostly woody material. But yeah, storing greens is difficult.
Yeah, you want to be able to mow your pasture and bring the green material in and right into the pile if you possibly can.
Yeah, Elaine, we usually, it's usually the same day. We have people mowing early in the morning, and it's in a pile within a few hours. I mean, even by the evening time, it'll start to brown out in the middle. So it's a challenge. It really is.
Yeah, I mean, anything you're going to get from a green waste facility that's local, it's going to have the yard trimmings of anybody and anyone. It's going to have unknowable amount of chemicals and things on it for sure. But it is something that's where we need to start going, though, because a lot of this material is just being ground up and they're burning it and turning it into energy, or somebody's trying to compost it. They're really just putrefying it and turning it into some brown dust, and then they can't even give it away. Some of these places, they're doing what they can to get rid of it. So
yeah,
I mean, that's
call it compost.
yeah, we're getting there.
We live in really, unfortunately, a toxic world now, and every single project that I've been on, and I hate to say it, we've tested the compost, we've tested the soil, and we're seeing extremely high levels of aluminum, barium, cadmium, arsenic. Hello, like, where are these things coming from? And I know that some of these metals, heavy metals, are coming from the soil, but a lot of them are coming from our atmosphere and coming from just other other environments. And with the grass thing, which I used to deal with a lot, and I still do, especially with golf courses that I work with, is that I try to find a way to dilute it, and just basically a filler. And if you can use a filler or somehow keep it from being so concentrated in the interim until you're ready to do something with it, that's your really best bet. And now some folks have been working with Akashi and EM products to break down these really toxic materials short term. But it's like you said, Keisha and Casey, it's these things are just, it's in everything. It's really tricky finding clean feedstock. It really is. So between what we're doing, and Elaine, I think Elaine mentioned this before, is that there's a lot of work that has been done and is being done with mycoremediation and bioremediation and phytoremediation. We were just talking about cover cropping, and all these plants can take up. We did a project where we put hemp in, because the hemp is known to pull arsenic up and more than other plants. And so there's all this work that's been done and is being done, and with the soil food web, we're talking about doing all that stuff. When you get that system really functioning and get that biological system really productive in the soil, all that is happening, that we're remediating those toxins, right, Elaine?
Yep. Yep, there really isn't any toxic chemical that we can't decompose by getting the right sets of microorganisms associated with it. Sometimes it's just figuring out exactly what is the mix of horrible things. And so what is the mix of the species of fungi and bacteria that we need to put in? I think we've got to take the same approach to that particular question that we take about what are the sets of organisms that we have to put it back in to regenerate this soil. We're just going to go for everything, maximize to the greatest degree possible. And so, like, we've just had the students in the courses here, in the foundation courses, sign up with an opportunity to have a class from Peter McCoy on mycorrhizal fungi, on soil fungi. And then one of the classes is trying to understand which microorganisms match up to which toxic chemical will those organisms be able to decompose. And so we want that whole mix. Just, okay, Peter, throw everything in a big inoculum, and that's what we've got to be putting into every single compost pile.
Yeah, we were just
More
talking
tools.
about it, Elaine, the idea of like when we do start composting these toxic materials in the same way that we create scenarios to select for certain microorganisms, we will start to see over time the organisms that are resilient they're gonna live and they're gonna multiply. And so I believe that in time we can create these cultures out of that waste to actually be able to break this all down. But yeah, getting to that point, that's where we can go.
The faster the better, but
Yeah.
I'm sure a lot of it's happening in most people's compost. These organisms we are putting in, a lot of them have those toxic, the ability to decompose toxic materials. So we're already doing it to some extent. It's just when you come to places that have been treated with dicamba, do you know that you? Yeah. So there's work to do.
Yes.
We need the Peter McCoys of the world, Paul Stamets of the world.
Exactly. Exactly. And I also think in compost in general too, the mindset traditionally has been around waste management is the focus, not about what kind of biology we can create. Unlike what you guys are doing, Casey, where it is around creating biologically complete compost, right? But I'm already starting to see some of the larger waste management facilities starting to think about, well, what is the biology that I'm producing, and how can I potentially market these products, and how can I change my practices to be able to produce a more biologically complete type of material? And that's encouraging to me that these are the municipal landfills and so forth that are starting to want to understand that in a much better sense. So I think there's hope for us to get this on a much larger scale, for sure.
Yeah, for sure. It's their waste reduction. They're not composting. You know what I mean? It's all it is waste reduction. They're trying to take as much bulk material and turn it into the smallest amount of something that they can, and that's what the composting system is right now on large scale in municipalities. So yeah, we've got to change that.
Yeah. Well, it's a huge opportunity for us too as a group.
Yep. To be able to do that. Exactly.
Clean it up. Got to clean it up.
Okay, next question. This one's from Zoe, and Zoe asks, how can we help farmers in their resistance, money, and fear to implement changes such as soil regeneration, regenerative farming practices, and to be able / encouraged to put cover crops on fields to increase carbon sequestration? So
boy,
that's lots of good answers. Yeah, it's a great question. We have a lot of good answers, I think, for this one too.
Well, I'll start off because I tell my clients all the time, I'm exposed to that question all the time. And, I tell them that, or I tell a lot of my classes and my students that one of the biggest challenge is not only transitioning the crop or the project, it's transitioning the client.
Mm-hmm.
So we focus, a lot of what we do is we focus in the marketing and the education part on transitioning the client and having them understand why it is we're doing what we're doing. And that's a really big component. So that's a really great question because, you could have the best tools in the world, the best program in the world, and people doing the project, but unless that client understands it, they're just going to be spinning your wheels. And, I have a client that loves to say if it works.
Yeah.
You know?
Mhm.
So, one day I said, John Doe, if you say if one more time, I'm done with this project, So, and that after that day, everything changed.
Yeah.
Understood. But you need to have that understanding right from the get-go.
I couldn't agree with you more. I think that is a huge thing. It's not just how can we get the biology out into the fields and to the plants. It's really how do you transition the mindset of that farmer? Because without that, they're going to continue to do practices that are again going to be harming biology, not benefiting the biology. And I also find too that with a lot of my client engagements early on, one of the things I really try to emphasize to them is let me spend an hour of our time educating you on the basics of the soil food web principles so that you understand what we're trying to achieve. And this will help you when you're going through and looking at your management practices to make that correlation of am I harming or am I helping, right? Harm versus help, harm versus help. And then the other thing, especially with the clients that are really kind of resistant, is we talk about doing trials. And I think it's good in two senses. One is it helps prove to the client that yes, these practices do work. But more importantly, and something I really try to tell my clients is this is your opportunity to learn the changes to your management practices at a small scale so that you can figure out how to then make this a large scale operation, how to make those changes within your organization at a large scale. So that usually helps as well.
Yeah, I mean, most of it is it's based around educating your customers. Like every time, it's such a huge part of what we have to do. Like a lot of people come to you with this idea that they're like, oh, I've heard about this biology thing. I want to make a change. Like what do I need to do next? And it's like, all right, let's get down to bacteria and fungi and protozoa. It's just like you start breaking them off pieces of the classes because, yeah, it's like Brian said, you have to understand what's going on under the ground to be able to know that what you're doing is actually benefiting that, so it's a lot of education. A lot of our customers, like if you buy a yard of compost, we're going to give you 15 minutes of talking about how to use it and why you use it and why what's in it is important. So
for sure,
that's a lot of education.
And the farmers are clever as well. I mean, they're a huge asset to help us figure out, how to scale things. They've been farming at scale for years, and so when we can educate them, we're just leading each other along the way, so it's a reciprocal learning environment. It's really nice, actually.
Yeah,
you nailed it, Keisha. It's really important to give the client the credit for moving forward, and that's a big one.
Yeah, agreed. And I think there's a generational issue too, that some of these farms, a lot of farms I deal with, it's multi-generational, and it's like my granddad did it this way, my dad did it this way, and I'm doing it this way. But they're reaching out to you for a reason, which is saying we're seeing challenges and issues. So they're 1 foot in, maybe 1 foot out, and the education I think helps bridge that transition much easier. Yeah.
And what's important from my experience, I find that if you have to be confident too. I mean, you've got to be doing this for a while. You got to be confident about what you're doing, what we're doing. But I find that if they're not going to commit, or if they are dabbling and they, if it works kind of thing, then you have to make the commitment not to work with them, because if they fail because they're trying someone else's thing and they're not committed to your thing, then you need to walk away. So you got to know when to draw the line in the sand, and because for all of us to be successful, we need that commitment. And if they make that commitment, we will be successful. Yeah. And so I think sometimes, not often, but people sometimes just want to get into the business, and then that person's trying this thing and that thing, and they're trying this system and that system, and they want to know why it didn't work. Right. And so, okay, well, you didn't follow the protocol here. Like,
you applied glyphosate.
Right. Exactly, Elaine. Exactly. There you go. They did that compost tea and they follow up with a fungicide.
Yeah, exactly.
And I've had that happen.
Put tons of UN32 on after you got good biology starting to establish the soil. Like, no, we reset ourselves. Yeah.
But, that's a really important topic, is this terminology transition. Mm-hmm. Everybody has their own way of transitioning, and as a group, we are learning from each other, but also there are protocols, right, Elaine, to transitioning corn or transitioning potatoes, or because all these different systems they use different fertilizers, different pesticides, different methods, different equipment. So how do you go about transitioning that particular crop or pastures, you know, so they're all a little different and they all have nuances. You know, the core of what we understand works, but it's also important to understand how to transition that particular. I know we're going off on a tangent here from that question. That's what happened with this group, but yeah. Well, anyway, sorry.
No, it's good. It's all good discussion. It is all related for sure.
Good point.
Yeah,
Okay.
it helps that most
ahead, Lee.
people aren't growing 25 different kinds of crops. They've got their two main staples, and then you can focus in on that with them and get them understanding what's going on the corn and the soybean.
Yeah. All right, let's take a question from Matt. We're going to dive a little bit more into the technical route here. Matt asked a question, can you describe some of the components of the large-scale extract systems and fertigation equipment? Is the injection using Venturi typically, the pumps used for large-scale boom sprays, etc.? Equipment comes up all the time. So anybody want to take this one?
Okay.
All right, yeah.
Go for it, Todd.
Well, again, I guess I've done a few. So unless, you know, Wes, maybe one of you guys can.
Well, I got something to say,
No,
but I'll wait till you get done, Todd.
I think what's the gentleman's name?
This is from Matt.
Yeah, Matt. I think the key here is it's really you know, when you're dealing with large scale applications, you got to be really careful with the whole activation thing. That's why we've really moved into more extract. You know, as long as you add the foods and the conditions are right, the biology will do what it needs to do in the real world, which is in the soil when you apply it, you know, or on the leaf surface. You know, the benefit of activating, as we know, we're growing out all those organisms exponentially, and we have more of a potent application or a potent biological mix, right? But when you're scaling up like that, there's so many things that can go wrong that makes it really, really difficult. From, you know, the farmer, the tractor broke, the guy didn't show up, deluges of rain, no rain, the list goes on, you guys. You know what these farmers deal with. So to simplify things, to be more consistent, when you're applying these extracts, especially in pivots and in tractors, so on and so forth, it's best to work with extract. It's all about managing the microbes in a passive way. You know, as soon as you overstimulate it, even if you're not adding food and you're adding lots of oxygen with aeration, they still will be stimulated and you'll start to grow out because there are food sources in there that will stimulate the bacteria, if anything, the bacteria, and you'll start getting that biofilm and you'll lose your shelf life. So I think the key is to passively manage the microbes, and there's many ways to do that, either vortexing or using, what we do is we oversize everything. The pumps are bigger, the valves are bigger, the hoses are bigger, and you know, it's really about passively managing the microbes until they're out on the field, in the soil, or on the plant. And so, and also another key factor here when you're dealing with this passive biology is everything that you have this biology in, you have a way of always flushing the system with water. So it's never really sitting in that place, even passively, for too long, unless it's being circulated. And again, passively. So I think that's the two key things here is oversizing everything, passively circulating the biology and getting it out that way.
Yeah, I think using your microscope is a key thing too, because a lot of the farmers are going to come to you and say, I want to reuse as much of my equipment that I have. And you have to make a determination. Again, is that harm or help, right? And really, I kind of put it in three categories: harm, neutral, or help. You know, in some cases, there's a neutral aspect to it. It doesn't harm or hurt, but it still may be a useful tool. And so when I go into a client situation and says, hey, I want to be able to use this spray rig and I want to be able to use these pumps to be able to move the liquid amendments around, we'll go in with my microscope and start looking at before the pump, after the pump, what kind of biological loss do we have, and make some determinations and saying that pump is okay, doesn't seem to be harming the biology, we can go ahead and continue to use it. Whoa, that pump right there, we saw significant biological loss. That is something that we need to replace into the system. And so I think, you know, we have some tools available to us to be able to help our clients be able to make some of those determinations on what equipment can they continue to reuse. Because for a lot of farmers, you know, buying new equipment, that's money out of their bottom line. And so they're going to be highly interested to make sure that they can reuse what they've got. And I think, you know, one thing you mentioned about large scale, fertigation, I think is a fantastic way. You know, people are already irrigating. It's a good mechanism to be able to distribute and get biology out into those fields. So fertigation is something that's very, very key. I use it a lot in my practice as well.
Yeah, that
Make sure all the emitters are.
some of those slides that I'd shown you back in 2000s, those were extract being loaded into those, downloaded to those 500-gallon tanks, and then the food was added, aeration, and then injected. In some cases, there's the food is actually applied just before application or with the application, so you're not overstimulating the microbes, especially in the big challenge, as you guys know, it's the hot weather.
Mm-hmm.
Yeah.
And
Yep.
people who take lunch breaks just after they add the food into the tank, and then they go take a lunch break. Great.
It is so much
Well,
active investigation, right? Like you said with the microscope. I mean, we've come in and just found, you know, there's no biology coming out into the tea, and just, you know, having to look at every step along the way and see, like, what is it that's blocking this issue? You know, is it the bag? Is there too much compost in the actual container? Are the pumps too big? Is there chlorine in the water?
Are there filters left on all of the pumps?
Yes.
On and on and
Oh my
on and on. It's investigation.
Rabbit hole.
Yeah,
Yes.
yeah.
Yeah, filters are just nuts. I can't tell you how many sprays I've got into where it's like, we removed all the filters. Okay, great. Go to start the pump. It's clogged. And then, oh, I didn't know there was a filter there. You know, after you spend a couple hours investigating, oh, there's a filter right there. It's like, okay.
Surprise.
Yep, exactly. Okay, that was a great question. Let's move to another question. This question's from DeGang, and the question is, hello everyone. On the efforts to keep beneficial microorganisms, how often is it that the conditions introduced to keep the beneficial microorganisms are also encouraging the growth of the harmful microbes?
Not going to happen.
Yeah.
Because the big condition that really helps us make an environment that the good guys are going to be growing is to keep it aerobic. Most, not all, but most, well, and especially the bad guys, the really, really bad guys, they require reduced oxygen conditions. So as long as you maintain oxygen concentrations above 6 parts per million, you're fine. You're going to be selecting for the beneficials. It's when you start to drop below 6 parts per million, more or less, you know, just to give you a cutoff value. That's where we start picking up the disease causers starting to multiply. And of course, as long as you maintain something aerobic, the disease causing organisms, enzymes won't work in an aerobic environment. So that's why the bad guys get growing in the anaerobic conditions. The good guys, their enzymes won't work in those anaerobic conditions. So it's a great way to separate out the good from the bad, and it's a good controlling mechanism. Now there are other kind of secondary things that we can choose, but that's a biggie.
It is interesting because in this system, by just controlling it, by controlling the anaerobic and aerobic reality, it's not like we're just killing off all the bad guys and they're gone now, right? Like, no matter where you look on the planet, whether it's in the best compost you've ever seen in your life, or, you know, just a puddle in your driveway, there's anaerobes and aerobes present. And so they don't exist at the same time. The system has to change for them to be activated and wake up. So, yeah, they just never really dwell together at the same time. It's
They're not active together. They may be present as spores, as dormant stages, and that's why, you know, people will, well, you know, when your compost gets really, really hot, doesn't that kill all of these organisms? No. If you're there and things are getting really hot, you go to sleep. You go into a dormant stage, and the hot loving bacteria and fungi continue to grow when the temperature is really high. But as that temperature comes down, those guys that were awake and functioning in those really, you know, 170, 175 degree Fahrenheit temperatures, they go back to sleep as you get down around 125, 180, whatever temperature So they're all still there, and that's what we want. We want diversity. We're going to just make sure it's the good guys that are actually growing.
And
But-
interestingly enough, when you build your biological diversity, you're looking at your aerobic organisms. If you take that material and drive it anaerobic, I do it all the time just for fun because I love watching affiliates. But what you'll observe is that your anaerobes become more diverse as well. You build diversity on both sides of the spectrum. It's not you're not just building diversity for the good guys. You're inadvertently building diversity across the board. And Todd brought it up earlier that people are using these anaerobic brews to break down these nasty materials. So in some ways, you kind of have to look at the bad guys as good guys too. In a certain situation, they're just what you need, you know, in the soil, on the planet to break certain things down. So diversity all the way across the board. It's pretty interesting, actually.
They have a role in nature, for sure.
Mhm.
Yeah, you know, one of the things I always look at too, and this gets into symptoms and causes. You know, if you are having disease outbreaks, you know, the mindset of today's, you know, conventional farmer is, I got a disease, I apply this, I go kill that disease, and with almost no thought of, why did I get the disease in the first place? What is causing this disease or this pest to come back over and over and over again? And really, one of the mindsets that we try to apply is, let's look at the cause. You know, why are you getting disease-causing fungi or pest outbreaks? Okay, then let's go. Oh, because your soil's compacted. You have anaerobic soil. The biology that's functioning in the soil is not the aerobic biology, the beneficial organisms that we need. We need to address those issues and then treat the causes, not necessarily the symptoms.
Yeah, I guess what a lot of people don't think about too is like if you have a fungal disease and you put a fungicide out, you kill all the fungi, not just the disease-causing fungi. And those are the most advantageous to return first. They're going to be the first ones to come back. You don't give enough time for the other things to come back. And so, yeah, you're going to be constantly applying this fungicide.
The fungicide vendors love it. That works so good for them. What, you need it again? Okay, I'm here.
But you're going to need a nastier one this time around.
Exactly. Unfortunately, it costs double what the last one that you put on there. So.
Really expensive to make. Really expensive.
Heard that story too many times. All right.
Speaking of fungicides, there are some really unique and interesting biofungicides that we are applying at the early stages of activation and growing them out inexpensively because they're expensive, as you guys probably know. And, you know, anecdotally, we're definitely seeing improvements. So I don't know if you guys have any experience with those biofungicides.
Yeah, we do, Todd, actually.
Bavaria Bassiana is one that we use a lot actually and it's like, man, it's like $80 for that pound of that stuff. And like, they say to use like a cup of it in like 50 gallons or something. And I'm like, there's no way. I mean, we were doing like 200-gallon teas and using like 2 teaspoons and getting incredible. And it was actually better because you're activating it. It's waking up. And then you're applying it, so it's already ready to go. You're not just throwing spores at a dartboard. You know what I mean? It's like,
we're actually watching the fruiting bodies come off the aphids and then spore again.
Right.
It works.
Your aphids turn into little white fuzz balls. Yeah.
Same with the fungus gnats. All of a sudden, you'll see teeny little white fuzz balls all over surfaces. It's pretty cool to watch.
Right.
What a bunch of nerds we are, huh?
Yeah, we are.
Things we get excited about.
It's also an endophite.
We're tangling again.
Don't get me on an endopath and nematodes. I'm coming on that road now. Well, essentially what it boils down to is there's a lot of tools that we do have in the biological means to help us. And, you know, and that's a good point. We tend to always focus, or at least, you know, the principle is to try to focus on the causes. But if you're working with a farmer that's got a cash crop that's about ready to lose their cash crop because they have an outbreak, that's when we have to go to our toolbox and say, all right, well, let's go ahead and use this biological method to be able to try to, you know, resolve this issue, treat that symptom for the moment. But let's not lose sight of why are we having those conditions in the first place. Yeah.
It makes you think, though, also of our role as an educator and kind of changing the mindset. And it's, you know, I've seen some incredibly healthy crops where you actually see some, you know, a problem pest. You might see it there. You don't see it everywhere. You look around and it, you know, one leaf catches your eye. You see the sign of that pest. And that may be the only leaf that you see. There might be another one But the key is they didn't overpopulate, and they won't overpopulate. And you can confirm just by using your microscope that they are highly unlikely to overpopulate and become the problem that they could be in the wrong conditions. And it's like you say, Brian, it's hard to not take that jump, because you could lose your crop. That's you could, if you don't know that, right?
Right. Yeah, exactly.
Yeah, if you don't have the knowledge that the microorganisms have been doing these kinds of controls for the last billion years.
Yeah.
No, the plant
Well, and I
essentially
think this
has
stuff.
to with the soil, right? And like seeing it actually activate and work like that, Wes, it can be one of the most challenging things ever to hold somebody's hand through that, to say like, you're just seeing it on one leaf and your soil looks like this, you're gonna be fine. You have to really trust the system.
Yeah,
We want to develop those predators, let them be. Don't kill all the ladybug larvae. I know they look ugly, but let them
Well,
eat.
and I think what we do ties in so well with the regenerative agricultural, broader umbrella. When you look at farmers that want to institute some kind of IPM, putting in hedgerows or pollination plants, or plants that really foster predators like predatory wasps and things like that. The practice that we do tend to really allow those habitats to flourish and to really grow. And so you can implement IPM strategies very well with the SFW approach. Whereas if you were spraying a lot of pesticides, well, if you just put it on a hedgerow with a bunch of good, species for predatory wasps or lacewings and things like that, and you just wiped it out with a bunch of pesticide, you set yourself way back. So this does dovetail very nicely into a lot of other practices. So I think in the long haul, regenerative agriculture is going to pull in the soil food web principles, IPM, and all those other good things. Okay, let's take one last question. And this question is from Roberto. And this one is, can the soil food web method treat Bermuda lawn turf that has been poorly laid over alkaline, rocky limestone soil at a new home? Or does turf need to be removed and relayed over a bed of topsoil? All right, turf experts, who wants to jump in?
Nah, you just have to get the organisms back into the system so they start making soil. Soil is defined as the sandstone and clay. You got that. That's that underlying rocky stuff. And you want the microorganisms to start chewing on that and releasing more of the nutrients. It certainly would help if you could put down a couple layers of a good compost with that biology and the organic matter with it, because those are the other two components that you have to make it soil. So, they put the sod down. If you don't have the organisms and if you don't have the organic matter, how much organic matter is coming in that little layer of sod? Well, not enough to keep anything alive through the whole entire season. So lots of compost, get it out there. The most productive soils on the planet are soils that are 100% organic matter. You don't need sand, silt, and clay. It's just an alternate form of nutrients that your plant can get hold of if it's got the right biology. But if you're growing on pure organic matter, of course there's all the nutrients. Everything has to be balanced in that organic matter, because once upon a time it was plants. So you need the organisms to release those nutrients that are in that organic matter. So I think we could just be recommending for people to put out a whole bunch of compost. Well, it's so expensive. Okay, well, get your compost and start working on the potting mixes, or whatever you want to, the cheap stuff, but get the biology back in there along with the organic matter, and you can build soil no time flat.
Todd said it earlier too, grasses they respond so well to treatment. And I always say just try to keep it simple. If you already have the turf there, you might as well try to treat it before, planning on doing something like pulling everything out and restructuring the soil and planting again. You might see really amazing results with just a treatment or two.
Yep.
Should be relatively easy with Bermuda grass as well, right? That is a relatively early successional grass. It grows by rhizomes, or runners on the surface. That's why it works well for turf. And really just introducing nutrient cycling. can work wonders for a crop like that, right?
And it's one of my least favorite grasses.
We do quite a bit of renovations. We do a lot of turf, and there's a lot of times that and a lot of people get involved in this where they're like, well, what do we do when the soil's so bad? Either it's toxic from all the chemicals, or it's just physically we talk about, right, the physical, chemical, and biological attributes of the soil, right? And a lot of times we just don't. It's not an option to rip the grass up and rip the soil and bring new, biocomplete soil. And like probably 90% of the time it's not an option because they have irrigation or they don't. It's big, huge expense. So and that's what makes what we do so unique, is that we can rebuild and restructure and make that soil productive again. So we do what's called, we do that lawn replacement or lawn renovation. And if there's still quite a bit of grass there, but it's just struggling because the foundation is garbage, then what we do is we open it up the soil, we core aerate it with heavy duty core machines, and then we come in and we'll broadcast the seed, and then we'll bring in a mix of either compost or compost and sand, or sand and compost, depending on what that original soil looks like, the physical characteristics. If it's really sandy, a lot more compost. If it's really compacted in clay, a lot more sand. But the sand and compost combination have been really working well for us, because the porosity and the weight of the compost helps drive that biology into those core holes. A lot of times the compost sits on top and it doesn't get into those holes. And the first, heavy rain that comes in, it really dislodges the compost. So that combination, getting it, just that right combination, we've seen really successful transformation of those lawns without tearing the whole thing up. And then we start to rebuild it. So that's one of the best ways to rebuild the existing soil without starting all over again. And it's a great time to get all the foods in there, to get the compost teas and the biology into those core holes. And then we always roll it at the end, not with a big heavy duty, a heavy weight roller, just a roller to compress the sand, compost, and seed together. And those make, we actually did a project where one side got rolled and the other didn't because the roller broke. And the side that we used the roller came up 10 times faster, filled in 10 times quicker. And so ever since then, we were like, okay, we always got to roll these projects. So, it's not a compaction thing as much as it is just, compressing the sand, compost, and microbes and seed together. And it holds, because we get these crazy deluges, and the bacteria with the glues and the glomalin really help it stick and hold in place.
Right.
That's my 2 cents.
Yeah. I was going to just, one story for myself is here in the homestead, when we live on a slope, and when we put our house in and a lawn in the back of our house, it was terraced, and we had a bulldozer and it cut all the topsoil out. It was pretty much just bedrock is where we put the turf on. And this is before my biological days, just right back when the chemical days. We put turf on there with probably a half inch of soil and then turf on top of that. And that lawn was pathetic always. It was constantly needing fertilization and so forth. Well, prior to me going to the whole soil food web route, we decided, you know what, we're going to rip out this lawn and we're going to put a food forest back in this super thin soil. I mean, there was really no soil there. And when we started applying the soil food web practices and the permaculture techniques of densely planting, putting a lot of crops that you could chop and drop, and just adding a lot of organic matter to the soil, I'm growing fruit trees, blueberries, much later successional plants that require a lot more soil profile than turf does necessarily. And it's one of the most productive spots on my property. So you can, in a very quick time frame, build soil and work on very poor, thin soils for sure. There's just no doubt about it.
Mm-hmm.
Your house is beautiful, Brian. It's true. I'm imagining it right now. It's what he says is true, guys.
I'm gonna go to my food forest.
Okay, I want to come see your house.
All right, Elaine. Make a trip
Elaine,
down.
get out here.
Yeah, it's time for a little vacation.
You got to come in right around end of July, early August, because that's when all the fruit trees are popping. That's when the plums are there. Asian pears are just starting to come on.
Just
yeah,
walk through.
These ferments are stocked on the shelf.
Exactly. Lots of yum.
It's both.
Sounds good.
Okay, well, you know what? I think that should put a book in it. I think great questions, everybody. So I'm going to give a couple thanks here. First, I'd like to thank the audience. Thank you so much for attending today's webinar and, listening to all the information that we had to share. And hopefully we start to see some of you folks in the Soil Food Web program and eventually see you as colleagues out there doing the good work. I also like to thank our panelists, Kishi and Casey. Keep it up with the compost. I believe me, I rely upon you guys immensely to make really good compost for my clients. Wes, same as idea. Keep on getting the soil biology reports out there and keep informing all your clients. And Todd, fantastic presentation. I know you're doing a lot of large scale stuff. You're really pushing the industry very well. So thank you.
Thank you, everybody. Thanks, Elaine.
Yeah, and Elaine.
I wouldn't
Todd.
have to do it.
Oh yeah, Elaine's got to. Yeah, so she's the only reason why we're here. You've taught us all and mentored us all. I can't say enough as far as I wouldn't be where I'm at today without the information that you've shared and given the guidance to me. So thank you so much, Elaine.
Thank you.
And one last
Thank you.
thanks. All the
You're all
people
doing
working on
good.
the background, Luke and Sammy, Maria, helping us moderate, keep the wheels running on this bus. Fantastic. So thank you everybody for keeping this thing humming. So with that, I think
Thank
we can
you,
go ahead.
Brian.
Yeah,
Oh
Brian.
yeah, Brian. Yeah. Oh yeah.
No problem.
The person
Love good
who
stuff.
narrates it all. Fantastic. Thank you so much, Todd, for coming today. And yep, we'll keep doing the good fight.
Exactly. All right. Remember, we have a webinar coming up on the 21st at 11 a.m. if I remember correctly, 7 p.m. London time frame. So if you want to get more Q&A and attend more of these sessions, please join us on the 21st. And with that, we're going to go ahead and close. All right, everybody.
Everybody.
See you all.